I came across recently some slight differences in the definition of skew between sort of Wolfram Cloud, Mathematica, and Excel. And so I wanted to dig down a little bit and sort of understand these differences. Now, the skewness, if you have a set of numbers, a list, a distribution, then you want to know that if it well, one simple definition is like if you find the median and you find the mean, are they the same? That's an indication, one indication anyway, that the distribution is symmetric around the middle. So do the two measurements of middle agree, and then for more of a definition of skewness is includes not just those two measures, but sort of some calculation involving all the points. Okay, so Excel, let's start with Excel. So I had some data, just generated some fake data, and now I'm going to calculate the skew. I looked in Excel, I asked, sort of went to the help, said, what's your definition? And it said, I'm looking at the, what's called a third a moment. I'm taking my data minus the average or mean. In this case, I'm dividing by the standard deviation and cubing all those. If you remember the standard deviation, you take the difference between a data point and the mean and you square it. So this is the sort of next higher thing. But also in terms of units, the standard deviation has some units and the skewness does not. So you take this difference, whatever units this data might have, you're taking the difference between a given data point and the mean, but you're dividing by the standard deviation, which has the same unit. So this is going to be a unitless quantity. So that's one difference between this and the standard deviation. Okay, but we're going to take that sum, we're going to take that difference, divide by the standard deviation, do the sum over all of the data points, and then their definition in Excel involves this n minus 1, n minus 2, the number of points. So I'm going to try and take them at their word and see. So I had my data, I calculated the mean, I did the median for fun. I don't really need that in this definition. And then there are two standard deviations, the sample and the population. And then I did a measurement of, then I did their calculation of skewness for the data. Okay. And Excel also has a thing called Skew.P, which we'll talk about in a minute. Okay. So here is that quantity cubed, this difference between the data point and the average, which was in E1, and divided by E3, which was the sample standard deviation, and cube that. And then I am here, this is me duplicating the Excel definition. I'm taking the sum of that quantity and then multiplying it. My E7 was my count, so I'm multiplying it by the count and then dividing it by the count minus 1 times the count minus 2, and then both in the denominator. And so this reproduced what just the skew. So this is what Excel is doing. And they have this other definition, Skew.P, sort of the similar difference between, I think, standard deviation.S and standard deviation.P. The P in standard deviation says this is the whole population, it's all there is, whereas the standard deviation.S imagines more data coming. Okay. So let's look at, this is the, over in Wolfram Cloud, this is the same set of data. And so I've entered that data and I've taken the skewness, and Mathematica likes to calculate things exactly and have numerators and denominators and square roots, and I didn't want any of that. So I put in this n, but I put lots of decimal places so I could see if what it was matching and what it wasn't matching. So this was matching 1, 2, 3, 5. This was matching Skew.P, not Skew. So we know what Skew is because Excel told us, and I did the calculation. So we saw that that worked out. And so we can also see, we can look up the documentation in Wolfram, but also because Wolfram Cloud will work symbolically, we can just sort of put in a bunch of symbols and calculate sort of a list of symbols and calculate their skewness and see what's going on here. And so I just said A, B, C, D, E, F, and you can see here, notice the minus signs in here. So this is A minus the mean, and that is cubed. And another data point is B minus the mean, and so on. And so we have that. So, and down here are I'm taking the difference between A and the mean and squaring it. So that, and then in the end, there's a 3/2 down here. So that compares to Excel of there was a, the standard deviation was the square of the deviations and then the square root, and then that is cubed. So this 3/2 corresponds more or less to this S to the 3, except in the normal standard deviation, you divide not by n, but by n minus 1. So you can see, and then there's over here, there's a square root of 6. So there's no 5s appearing. That would be n minus 1. There's no, I don't see any 2s, sorry, any 4s, but the square root of 4 would be a 2. So that's a little harder to find, but we don't have any n minus 1s here in this definition. But but this must be, this definition that only seems to involve n, but not n minus 1, not n minus 2, seems to be the one that agrees with the Skew.P definition in Excel. Okay, so now I know what Skew does in Excel. I can sort of see what Skew.P, Excel has Skew and Skew.P, so I can see that what Mathematica is doing is what Skew.P is. And then from comparing this definition in Excel and putting sort of, and realizing that the standard deviation has an n minus 1 in there, I can see that to go from the E8, which was the standard deviation, or sorry, the skewness, and if I multiplied it by n minus 2 divided by the square root of E7 and times E7 minus 1, this is, we're playing around with n and n minus 1, so I can get from the skew, I probably should have done this the other way around, but if I'd done this the other way, then I would have gone from, right now I'm going from the skew to Skew.P, and I could have done it the other way around, and then you would see the n minus 2 in the denominator saying that this should, that Skew like would blow up if there are only 2 points, so that it's got an idea of, if you did the skewness of something with only 2 data points and just treated it as a population, it would just tell you 0, it's not skewed. Whereas if you imagine more, if you're taking this more sample approach and saying more points were to come, then you would say undefined. So this skew in Excel is imagining like more points might be coming, whereas a Skew.P does not, and Skew.P is also what Wolfram Cloud does. And I also did it over in R. I had to bring in a sort of a package, a library moments, and then this is the same data again, and I calculated its skewness And which one did that? So that was the standard deviation. And here is my skew 0235. And so 0235, that agrees with Skew.P and with Mathematica. So the definition that comes in with this library in R and Mathematica agree with what Excel calls Skew.P. But Excel's definition of just skew is trying to account for this idea of that it's a sample, and so it will be undefined for 2 points, and they will approach each other as there are a large number of points, as all these things do. Okay, just I was curious, so I thought maybe other people would be. Thanks for your attention.